Hi guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we'll be having a look at definite integration. So before I commence, I would recommend you watch my two other videos under the playlist of integration, that is the basics of integration and integrating using the reverse chain rule, as the basics of those two videos is basically the ground foundation of this video. So without any more delay, let us begin. So in all, we have two types of integration. We have definite integration and indefinite integration, as I've previously discussed. In definite integration, we have bounds or limits. They both mean the same thing, just differently said, and that's when you have integers on your integral sign. This is an example of definite integration, and indefinite integration is when you simply have this without any integers. In indefinite integration, when you are done integrating, you always add a plus c. However, in definite integration, you do not. So how exactly does definite integration work? It's basically the same concept. You integrate, it's just that these two values are the major role players. For example, let's say I have to find the definite integral of x, but with the range of, let's say, 4 to 1. Now, one rule of this is the upper limit. This is the upper limit, or upper bound, same thing. We'll stick to upper limit, is always supposed to be greater in value than the lower limit. Lower limit. So this number, as you can see, 4 is greater than 1. And all you have to do from here is just integrate x. We know that when we integrate x, this is the same as x squared over 2, and then simply substitute your values of 4 over here into x, and then whatever you have there, you then put 1 and then subtract that from the value of 4. So if we put 4 into x over here, we have 4 squared over 2, that's 16 over 2, that's 8, and then you do minus when you put 1 over here as x, that's 1 squared, that's 1 over 2, 8 minus 1 over 2. And whatever that gives you as your answer, I think that is 15 over 2. Let me just confirm real quick. 8 minus 1 over 2. Yeah, 15 over 2. So that's basically how you do it. Now, usually definite integration is used in questions involving area under the curve, or a shaded area bounded by some region, or the volume rotated. So in those cases we use units. If it's about area, we would use units squared. We would write this after our answer. And if it was in terms of volume, if the question is about volume of rotation through the y-axis or x-axis, then we use units cubed. Now, one other important thing to note is that your upper limit is always meant to be greater than your lower limit. Now, this may not be the case all the time. It's very rarely this happens, but it can happen. Sometimes questions are twisted, and they could ask you to integrate, let's say, something like 1 to 2 of x again. Now, you know you have to manipulate this question, because this is not possible. Your lower limit should not be less than your upper limit in any case. So all you have to do to rectify this is simply switch these two around. But when you switch them around, add a minus sign to the integral. So from this it becomes the 2 to 1 integral of x. Just add a minus sign over here, and you have rectified it. And then you can proceed with your normal integration, and whatever your final answer is, just add a minus to it. Of course, if your final answer is a negative already and you add another negative, then you have a positive answer. So let's go and dive right into our first example. Our first example states to integrate 2 to 1 of 2x. Now, to go about these questions, the safest way to start is by writing the question again. That's 2 to 1 of 2x, and then just write dx. This dx shows that this is being signified as a dy dx, and you're trying to integrate it to get an equation. However, that works more or less in indefinite integration, but in definite integration it's always safe to write dx. Some exam boards do give marks for these, some do not. So depending on your exam board, you can either have this or omit this, but it's up to you really. No harm in writing it. Now from here we just need to integrate this. So from here we can use square brackets 2 1 and then integrate our variable. 2x integrated is 2x squared over 2. You add 1 to the power and then divide everything by the new power. This can cancel this, so you can rewrite this as 2 to 1 of x squared, and all you have to do now, input your values. So you put your 2 over here, that becomes 2 squared, minus you put your 1 over here, this becomes minus 1 squared, which is minus 1, still 1, and then this is 4 minus 1, and that gives you 3. And that's the final answer for that question. Now on to the next example. It asks us to integrate 2 to minus 1 of 2x plus 4. Again, same way we go about this. We have 2 to minus 1 of 2x plus 4 dx. Next we can proceed with our integration, so we can use our square brackets. 2 minus 1, integrating this we have 2x squared over 2 plus 4x, and again this can be simplified further. This cancels this, we have 2 to minus 1, but here we can have x squared plus 4x. Now from here, same procedure, input our values. We will now have 2 squared plus 4 into 2 minus brackets minus 1, or squared plus 4 into minus 1. Doing the left hand side, 2 squared, that's 4, plus 4 times 2 is 8, that's give 12, minus 1 squared is positive 1, plus 4 into minus 1, that's minus 4, 1 minus 4 is minus 3. Now again, if you have something like this, we know that 2 minuses end up giving a positive, so 12 plus 3, and the answer is 15. Be careful, because minus is the most dangerous sign in mathematics. Right, on to the next example. Next one asks us to integrate 4 to minus 5, or minus 5 to 4 rather, of x cubed plus 3x. Okay, same way, 4 to minus 5 to go x cubed plus 3x dx. Next up you do your integration, so 4 minus 5 square brackets, this is x power 4 over 4 plus 3x squared over 2, close the brackets. Now from here, if you want, you can rewrite this as 1 over 4 x to the power 4 plus 3 over 2 x to the power 2. It is basically the same thing as this. It doesn't really further simplify it, so we can directly go ahead with this. We plug in our values as we have been doing, so this becomes 4 to the power 4 over 4 plus 3 into 4 squared over 2 minus, we now put the minus 5, so minus 5 to the power 4 over 4 plus 3 into minus 5 squared over 2. So going ahead with your calculator, if you use it, left hand side gives 88 minus the right hand side gives minus 193.75, and doing the necessary calculations, this ends up with minus 105.75. Again, depending on the question and whether they ask you to give your answer to a specific format, you can leave it as decimal or as a fraction if the question asks you as a fraction. On to the next example. Next one says we have to integrate 2 to 4 of 8x to the power minus 3. So as usual, we do our normal proceedings. 4 to 2, this is 8x power minus 3 dx. Go ahead and just keep that in brackets. Next up, we integrate the 8x to the power minus 3, so we have 4 to 2 square brackets. This would be 8x to the power minus 2. We add 1 to the power divided by the new power, that's minus 2 dx. This cancels this to give minus 4. Okay, you can, sorry guys, you don't need to write dx again over here. This cancels, 8 divided by minus 2 is minus 4 basically. So this is 4 to 2 minus 4x power minus 2. Now again we do the same that we've been doing. I'll plug in 4 over here and then plug in 2 over here and then subtract them. So minus 4 into 4 power minus 2 bracket minus open bracket again minus 4 into 2 to power minus 2 close bracket again. Left hand side gives minus 1 over 4 minus 1 and then minus 1 over 4 minus 1. These two end up to give a positive, so we have minus 1 over 4 plus 1, and minus 1 over 4 plus 1 is 3 over 4. And that is the answer to that question. Yeah, on to the next one. Okay, it asks us to integrate 0.5 to 2 of x squared plus 3x plus 4 all over x to the power 4. Just a second, let's write that. Yeah, and this is a challenge question. So do pause the video and have a go at this by yourself, and then resume the video to see if you are correct or incorrect. If you are incorrect, please take note of your mistake. Right, so same way we go about this. First things first, we write the question. 0.5 integrate of x squared plus 3x plus 4 over x to the power 4 dx. Now the best way to go about this is to rearrange this so that we can work in it in a better way. If I rearrange this by taking this up top, I'll have something like x squared plus 3x plus 4 into x to the power minus 4. Because I take the power to the top, to the numerator, from the denominator the power becomes negative. And from here I can expand the brackets. I can expand this by multiplying by this, then this by this, and then this by this. So x to the power minus 4 times x to the power 2 gives x to the power minus 2. If you remember your laws of indices. If you're not comfortable with laws of indices, you can watch my video on laws of indices. That will really help. We know that when we are multiplying powers with the same base, we add up the powers, and minus 4 plus 2 is minus 2, then plus 3x to the power minus 3, because x times 3x would give 3x obviously, and then the x to the power 1 over here, so minus 4 plus 1, or 1 minus plus 4, same thing, would give minus 3, and then 4 plus 4x minus 4. Because there's no power over here, so the minus 4 plus 0 is still minus 4. So now this is what we're going to integrate. So we can go ahead and use our square brackets now with 2 to 0.5 and integrate this. X to the power minus 2, integrating it, we have x to the power minus 1 over minus 1, because we add 1 to the power divided by the new power, plus 3x to the power minus 2 over minus 2 plus 4x power minus 3 over minus 3. Now we can simplify this to make it easier for us. We have 2 to 0.5 square bracket. We know there's a 1 over here, so this cancels this. We basically have a minus x power minus 1 minus 3 over 2x to power minus 2 and minus 4 over 3x to power minus 3. Why did I get minus over here and over here? Is because if I do 3 divided by minus 2, it's minus 3 over 2, and plus minus 3 over 2 is the same as minus 3 over 2, because the minus overweighs the positive answer. Same over here. So that's how I get the minuses over there. Now, as we have been doing, this might be a bit long, but we just substitute our values. We would now have something like this: minus 2 to the power minus 1 minus 3 over 2 into 2 to the power minus 2 minus 4 over 3 into 2 to the power minus 3. Subtract all of that, or what you're going to subtract from all of that is now going to be minus 0.5. Remember, 0.5 is the same as 1 over 2. If you're not comfortable with decimals, you can always use fractions. To the power of minus 0.5, minus into 0.5 to the power minus 1, minus 3 over 2 into 0.5 to the power minus 2, and then minus 4 over 3 into 0.5 to the power minus 3, I believe. Yeah. So putting all this in your calculator, be extremely careful, because any little mishap with the powers or the signs can completely alter your answer. So the left hand side gives minus 25 over 24 minus, and the right hand side gave minus 56 over 3. So you obviously add up these two, because 2 minuses give a positive, and this ends up giving your answer as 141 over 8. Now, a lot of times questions do not like their answers to be in an improper fraction, and 141 over 8 is an improper fraction, so converting this to a mixed fraction, your answer can also be the same as 17 into 5 over 8. Or if they ask it in decimals, or if it's safe to ask in decimals, then you can do 17.625, depending on the amount of dp it asks your answer to. And there are 3 answers for that question. They all mean the same thing, just different ways of writing it. So as you can see, this one took a bit long. Really, the hard part really was this part, just to rearrange and manipulate it. So that brings us to the end of the challenge question, and to the end of this video as well. Thank you for watching. Hopefully you enjoy it. Please do not forget to perform an LSS, that is like, share and subscribe. Also feel free to ask any questions or give any feedback in the comment section below. Thank you for watching. Have a nice one, guys.